Okay, trying to get caught up now since I got my voice back. So let's look at this one here. These are the other ones that can help you. Cosine of 270. Don't forget when it asks you for these pieces, this is your standard position. That's where it's at. So that's where it's opened up to. So if we draw this thing, don't forget to draw them. If we draw this thing, we're going to open up into the standard position. That's 270 degrees. Well, since we want the exact value, we have our x, we have our y. This is on the unit circle. So this has gone left and right 0, and it's gone down -1. Since we know that cosine is our x and sine is our y. So the cosine of 270 degrees is equal to 0. So these ones on the corners, you got to use your unit circle to kind of adjust to them. When it comes to dealing with something like this, cosine of 7 pi over 3, we need to know, again, here's my standard position. So we know this thing is opened up somehow. I know that this is going to be right here. It's going to start and it's going to go right to here. And I know that that's going to be 60 degrees. I know that just because I know how radians work. If you're not sure how that works, let's convert this to degrees. Oops, that should be a pi. If we convert that to degrees, those are going to cancel. 3 goes into 18 6 times. 7 times 6 is 42. So this is 420 degrees. And the nearest x-axis is 360 degrees. So that means that this is 60 degrees, which is what I came up with right there. So there's multiple ways you can find this thing. Now, from there, I know that I've got a 60-degree special right triangle. 60 goes here. That's my reference angle. And then across from 60 is √3. My hypotenuse is always 2, and then I got a 1. And I want the cosine. Cosine is equal to adjacent, which is 1, over the hypotenuse. So my cosine, it should read cosine of 7 pi over 3 equals 1/2. That's what I'm looking at. That is an incorrect way to write it. That's what it should look like right there. So if you can't figure out where this is, just convert to degrees. That'll help you out on, especially on numbers 20 through 25. Tangent of 5 pi over 4, you can try on your own. Man, this is a big one on the test where they give you -√3 over 2. This is the one that says find the angle that represents the point. This will help on the test. You've got to be able to figure out where you're at. And we'll go 1/2. Let's say that's point P. Sometimes they're written like this. Let's see, negative and up, so it's going to be up here somewhere. And they say, oh, we've got an M here, and we've got point P there, and they draw a line. And they talk something about an arc and all this different stuff. Kind of look at this. This is just standard position. I'm writing real funky because I'm trying to keep my hand out of the shadow. This is just your terminal side, and your points create a triangle. So if my points create a triangle, I'm looking at the fact that this is -√3, this is 1, and that's 2. Remember, your denominator, when you're given a point on the unit circle, is always your hypotenuse. So this is what I'm looking at right here. So if I know that across from the 1 is always 30 degrees. Some of you are like, how do I know that? It's just something you're going to have to memorize, guys. There's no other way to look at it. So across from the 1 is 30 degrees, or if you look at it, √3 and 30 are right next to each other always. That's another way you can look at it. So since that's across from there. That's 30 degrees. And this is 180 degrees. If I go back 30 degrees, that means that this angle is 150 degrees. Start working your way through those types of things. Just remember, you're always dealing with a special right triangle and working with those types of things on there. And that's the second video.